Hi, in this lecture we're going to discuss about the image that is formed by refraction. Right, so now let's consider a transparent media. Right, one is here, right, and one you can consider as air, right, and N2 another media that has higher density. Right, so N2 is bigger than N1, and if they have a boundary between them, and the boundary between these two media are in the form of spherical surface with radius r, right, this is the radius, it has a spherical kind of shape. If the object at point O, right, its origin here, so the ray that is originate from the object, right, this ray, right, when it passes through or when it falls onto the surface of the spherical surface here, according to law of refraction, it will be refracted. All right, refracted closer to the normal, all right, respective to the point of the refraction, all right, here, and here. And according to law of refraction, the angle will be this way, this way, this way, and so on and so forth, right? And at certain point, this ray will, right, not appear, right, they will combine, right, or focus at this point I, which is the image point, right? So therefore we can identify the position of the object, which is distance p, while the image have the distance given by q. And the relationship between the position of the object, the position of the image, is given by this equation, where P is object position, Q is image position, N1 is the index of refraction in medium 1, N2 is index of refraction in medium 2. We have equal to the difference in terms of the index divided by the radius of the curvature. Alright, so in this case we have the side of the surface which the light rays originate is now defined as the front side, right? So that is the same as the mirror case. We have another side is called the back side. All right, but now because of the refraction process, we have a real image is formed by refraction in the back of the surface, right? We have real image formed in the back of the surface. Compared to mirror, we have virtual image formed at the back of the surface due to reflection, right? And because of this convention, all right, the sign convention now change, right, for Q and R, and it will be the opposite of those mirror. So let's have a look at the sign convention for refracting surfaces, right? So we have object location P. If the object is at the front surface, it will be real object. And if the object is at the back of the surface, it will be a virtual object. And effectively, the image location Q, if it is at the back of the surface, it will be a real image. However, if it is at the front of the surface, it will be a virtual image. In terms of height, H, all right, the height of the image, right? If height is positive, then it is upright. However, if from the calculation, if the value is negative, then it will be inverted or upside down. The value of radius r is positive is the center of curvature is in the back of the surface, right? Just like in this example. All right, so r value is positive in this case. However, if it is the center of the curvature is in the front of the surface, it will be negative value. That is the sign convention for refracting surfaces. Right, now let's have a look at the case where we have this kind of phenomena. Right, we have a flat reflecting surfaces instead of curvature surfaces, right? So when we have r is when we have the surface is flat, all right, then the value of r is infinite. All right, if you can imagine r is small value with this circle, and then the value of r will be increased with this value with this circle. All right, and then it will increase more and increase more, and up until this point the r is considered as infinite, right? So when the r is infinite, if we replace r here with infinite number, so anything divided by infinite, it will become 0, right? And if we rearrange, right, this equation, we will get this equation: q is equal to minus n2 over n1 over multiplied by p, right? So as you can see in this case, right, if the object is here, we have a flat surface here, not a curvature, all right? Then we have the ray emerge from this point from the object, and then after it reach the surface, right, the flat surface here, right, flat surface here, according to law of refraction, it will be refracted away, right, from the principal axis, from the optical axis, right? So when it's refracted away, different angle will be refracted at different value, right? All this, if we trace, right, we will find out that they appear to diverge from this point, right? And that will be the position of the image, and therefore the distance between the image and the surface will be the value of q, and again the distance of the object will be p, and we have this equation to describe the position of the image, right? And from the consideration that the image is appear to diverge, therefore we have a virtual image is formed. Example here, we have a fish that stays somewhere inside this, let's say, aquarium or something, right? It has distance d, so that is the object distance or object position d, right? And that is actually p, right? And if you observe from here, then the fish actually appear, it is located here, which is basically the position of the image, right, due to refraction here, right? So the rays appear that they are diverged from this point, right? And we have the value of index of refraction in air is almost equal to 1, and index of refraction for water is 1.33. Substitute into the equation, this equation. Then we have in terms of depth, right, or d, the position of the image is 0.752d, so it is basically about 75% or 3/4 of the actual depth. All right, the position of the fish. And negative here means that the virtual image is formed. We can do further analysis in terms of the size or the height of the fish itself. All right, so how can we compare the real height of the fish with the apparent or the height of the fish that we observe due to refraction? All right, so if we consider the height of the fish, which is d plus h at the bottom fin, and d is the top of the fish, all right, and if we consider both point, and then the height is given by the difference between these 2 points, which give us around this value. That is the value of height of the fish, which is interpreted as the fish is also have 3/4 size compared to the real value of the height of the fish. Right? Okay, so that is the discussion about the refraction, right? Image that is formed by refraction.